This session is titled Scaling .NET Containers with Event-Driven Workloads. So it is going to be conducted by Nilesh Gule. So Nilesh Gule is the third MVP for today. We already had the pleasure of attending lectures from two different MVPs today. He is third in the series, and Nilesh is passionate about software with a motto of code with passion and strive for excellence. Right? He is, as I have told you, he's a Microsoft MVP on Azure platform, and he is a hands-on data architect with more than 18 years of industry experience in finance, retail, and healthcare domain. He is also a blogger, speaker, and technical evangelist. And when he is not thinking or talking about technology, he likes cricket just like every other Indian does. So I'm sure in today's particular session on Kubernetes-based event-driven autoscaling, that is EDA, KEDA, he will be doing a deep dive and exposing various nitty-gritties of Azure Kubernetes service clusters, and giving us a very close encounter with this particular technology. So Nilesh, without consuming much time, I would first like to thank you for devoting your time for this particular purpose of SURATi iLab, and also would like to invite you to take control of this session and start your presentation.
Thank you. Thanks, Tejas, for the introduction. Before I start, just want to confirm you can hear my voice?
Yeah, I can hear you.
Okay, so let me start by sharing my screen. Can you see my screen now? Okay, so thank you. Thanks for giving a quick introduction. You saved me a little bit of time by giving whatever I had put in my speaker bio. So in case you would like to connect with me, I'll put the social media handles to my Twitter, GitHub account, as well as LinkedIn. So feel free to connect with me after the event. Just put a comment that you are part of this event so that I know why you would like to connect with me. I'm also the co-organizer of Azure Singapore user group, and since COVID stuck, we have been doing a lot of useful sessions with cloud advocates, MVPs, and other people. And I thought it might be useful for the audience in this session also to subscribe to our channel or to go through some of our sessions. We have had sessions by people like Scott Henselman and various other well-known people in the industry. So feel free to hit that bit.ly link, which is Azure Singapore sessions, and I'm sure you would find a lot of useful sessions there. A bit about myself: I was born and brought up in Goa. So just like Gujarat has a distinct set of attributes when it comes to the way people behave, the way people eat their food and things like that. Goa has a distinct culture, and if you know, Goa was not part of the British colony, but it was a Portuguese colony. So you find a lot of distinct architecture traits when you visit Goa. Many of the Bollywood movies show Goa as a place for hippies, but it's not just about churches. There are some beautiful temples in Goa, and if you happen to visit Goa sometime in future, I recommend that you visit some of these historical places. Now, coming back to today's session, what I'll be talking is, here is the agenda. We'll start by looking at what are the different options for scaling in Kubernetes. Then I'll give you a quick overview of KEDA, which is a project or a platform which is based on Kubernetes-based event-driven autoscaling. And then I would have a live demo of a small demo app called as TechTalks, which is using RabbitMQ as a messaging platform. And we will see how to implement event-driven scaling with KEDA and with .NET as the programming language. But whatever I show here can be applied to other programming languages, be it Java or Python, Node, or other languages like Go as well. Expect the attendees to know this is slightly advanced topic. So since we are talking about cloud native applications and containers and Kubernetes, Docker is like a prerequisite. So if you don't know about Docker, it's a way of building applications in a self-contained manner with all its dependencies. You create something called as Docker images, and then we orchestrate those images using Kubernetes. So Kubernetes gives various different facilities or services. Some of them include orchestrating the containers. It also has features like self-healing. In case something goes wrong with the running application, we can configure Kubernetes in such a way that it can automatically restart the service or the workloads. There is service discovery, and we'll be focusing on scaling. Scaling is because nowadays we are talking more and more about cloud native applications and things which are event driven. We are moving away from batch kind of processing, and most of the applications now they are targeting to go microservices way with event driven architecture. So that is where scaling comes into the picture. And then I also expect the attendees to know a bit about container registry. It could be Docker Hub or a private container registry like Azure Container Registry, or the other providers like EKS or AWS has their own container registry. So this is the place where we store our Docker images, and they can be pulled into the target environment. And I'll be using Azure Kubernetes Service, which is the managed Kubernetes service provided by Microsoft Azure. So this provides various built-in capabilities, like it is fully managed by Microsoft, and then it has native integration with services like Azure Active Directory, Azure Container Registry, Azure Container Instances, Azure Monitor. So these are all like value-added services, I would say. A bit of knowledge of AKS is enough, but if you don't know AKS in specific, but you know a bit of Kubernetes, that would still do. So let's look at what are the options available when it comes to scaling in Kubernetes. I would like to highlight three major ones here. First one is what is called as the horizontal pod autoscaler, or HPA. In this option, we can configure a horizontal pod autoscaler. So pod is like a basic unit of execution in Kubernetes, and we can define resources. We can put a limit, as well as we can request for resources. So when a pod is getting scheduled on a cluster is combination of your nodes. So we can say my pod requires, let's say, 100 MB of or one CPU and 100 MB of RAM. That is the requirement to start. And then we can also put limits saying maybe maximum amount of resources that it requires is 2 and 500 MB of RAM. So in this case, we can define based on these resource limits a horizontal pod autoscaler to automatically scale the number of pods. So when the resource limits or resource usage reaches, let's say, 60% or 75%, I can configure a horizontal pod autoscaler to automatically scale, let's say, add 5 more pods. And same way, it can scale down as well. So there could be a cooling off period, let's say 2 minutes or 5 minutes. And if those scaled up resources are not used, it can scale down automatically. So that's the automatic part, or the horizontal pod scaler part. The next level of this is the cluster autoscaler, where let's say you have a 10 node cluster, and your horizontal pod autoscaler decides that it needs to scale more, and it requests for 100 pods to be scaled. But the amount of resources that is available within your cluster, within those 10 nodes, is sufficient only to service, let's say, 80 pods. Now there is a shortage of 20 pods. They cannot be scheduled because there is not enough resources. In this case, we can configure the whole cluster to be auto-scaled, in which case additional nodes will be added to the cluster. And same way, when the resource usage is going down, when those resources are not required, it can be scaled back again. The third one is manual option. So I'm sure many of us have been in situations where there is one person in the team who knows exactly when everything is aligned and we have to manually scale. So it could be based on, let's say, month-end processing or quarterly processing. And these are like the activities where once in a while you need to scale, but you don't really need an automation around that, or you don't need these things like the cluster scaling or horizontal auto scaling. So let me show you a quick example of this manual scaling. and then we will go into the demo. So I will switch to the terminal here, and I'm using Windows terminal. So this is the emulator which I use. And let's look at first what are the different deployments that I have. I can scale different things like replicas, deployments, and if I do like kubectl get deploy, currently in this particular cluster, I have got two deployments which are deployed. One is the RabbitMQ consumer, and the other one is RabbitMQ producer. And right now, there is 0 instances or 0 replicas of this consumer deployment running. So let's go and scale this to, let's say, 2 replicas instead of 1. So I want to create 2 replicas of my consumer. And if I run this kscale deploy, name of the deployment, RabbitMQ consumer deployment, and give replicas flag as 2, we will see that this has been scaled quickly because the images are already there. They are already pulled in the cluster and they would quickly be started. So if I go back again and query for those deployments, now we should see that there is 2 instances of that. Right now, one is ready, and shortly, another one also will be ready. So if I query after a short period of time, we should see that 2 of 2 replicas is ready. So this is manual way of doing. So now let me show you what I'll be using as a demo for this. So for the demo purpose, I have a small application which is called as TechTalks. You can think of this as a small like event management kind of application. And there are 3 components to this application. First one is the producer, which is a .NET Core API. I have 2 instances of this deployed in the cluster, and this is exposed as a Kubernetes service using the load balancer. So even though those 2 pods are running on different nodes, I can access them using service, and I'll be exposing it outside of the cluster so that we can call it from outside the Kubernetes cluster. So that is why I'm using a type of service, which is load balancer. Next, we have the consumer, which is consuming the messages. So the producer is going to create a set of tech talks. We can specify the number of messages or number of tech talks that we want to create. And then the consumer is the one who is going to consume this. So the consumer is a .NET Core EXE. It is not exposed outside the Kubernetes cluster. It runs as a normal deployment, and behind that deployment, a set of pods are running. And the consumer is configured to process these messages in a batch. So we can configure how many number of messages have to be picked up in a batch. And currently I have configured it to pick 75 messages in one batch. And finally, we have the messaging infrastructure, which is RabbitMQ. So the RabbitMQ is running again inside the cluster using a Docker image. This is exposed using a Kubernetes service, and this is using a cluster service. This is not exposed outside the Kubernetes cluster. So we use Helm chart to deploy RabbitMQ, and then the producer and consumer, these are deployed using Kubernetes manifest files. So these are like YAML files which describe various attributes, how our deployments have to be configured, or how these workloads have to be configured on our Kubernetes cluster. So we use manifest files for deploying our producer and consumer. We use Helm charts for deploying third-party application, which is RabbitMQ. We will be using a tool called Octane to visualize the state of our Kubernetes cluster. It's an open source visualizer for Kubernetes. And we will work with kubectl to deploy the manifest if there is any need to deploy them. And we will use Postman to generate the workload. So let's go and look at how this application we can use it. So let me go to the browser and quickly show you the Octane view of what is deployed. So whatever we can, okay, we lost connection to Octane. So let me restart it. I'm seeing an error here saying it might impact my audio quality. Is the audio clear on your side? Are you able to hear me clearly?
Yeah, it's very clear over here.
Okay, thanks for the confirmation.
But there are two rectangles which are appearing on the screen, so I don't know how it has come up.
Oh, you're not able to see my screen?
We are able to see the screen, but there are two rectangles which are redacted. So yeah, now one has gone, but one on the right hand side is still there. Yeah, that one.
Okay, how about now?
Yeah, it's gone now.
Okay, fine. Thank you. So I'm just restarting the Octane, and once Octane is started, this is the UI it presents us with. So we can get to see all the state of the Kubernetes cluster that we have. And this is the demo effect where it starts to slow down during the demo. Okay, it's up. So we can see the workloads, we can see what are the services and the pods running the load balances, if there are any config maps, if there is any persistent storage or volumes mounted, if there are any custom resources, we can visualize all those using Octane. So we can see that right now there is a consumer deployment and RabbitMQ producer deployment. So two deployments which are specific to my application. There is a RabbitMQ pod running here. And then there are the two pods for the producer. So the consumer pod that we scaled has been killed, or it got terminated. So let's go and scale it again so that I can show you the workload. So let's first check the deployment again. It has gone back to 0. So let's scale it back to 2. It is scaled back to 0 because of the framework that I'm using, KEDA. So in a short while, you will realize why it's going back to 0. This doesn't happen in the normal deployments, but because I use KEDA, it is using this automated way of scaling down to 0. So now it is scaled back to 2, and we should be able to trigger the workload. So let's go and first deploy, or let's populate some messages in the producer. So if I do get and get the service, I need to get the public IP of the producer service so that I can generate the workload. So this is the 20.198.138.188 public IP. And the same thing we can see using Octane. If I go into the services, Octane will show me the public IP of this service. So let's go into discovery and load balancing. And if we go to services here, we have the RabbitMQ producer service here. This is the IP that we need. So I can take this IP and go into Postman and put this get request for the TechTalks API. And there is a generate method which takes the number of messages as the parameter. So let's go and generate, let's say, 3,500 messages. And before I do that, I just want to confirm that there are no messages in the RabbitMQ. So I have a RabbitMQ UI, and you can see that currently there are no messages here. And I also want to check, let's start with this. So I go back to Postman, and if I send this get request, and if I get the status as 200, that means those 3,500 messages would have been populated. So I get 2,200 as the status. And if I go back here, I should see here. Now 3,500 messages are there in our queue. RabbitMQ has this many messages. And if we look at the consumers, we should be seeing those two consumers that we have. So let's go back and let's do kget deploy. it's gone back again to 0. Let's scale back to 2. Okay, so now we should see 2 consumers here in a short period of time. 1 consumer has started, and we can see that 75 messages has been picked up by this 1 consumer, and now it's growing. Okay. The reason for this is SCADA is already active, so that is why, okay, this went 1 step further. But okay, so what we will see now here is, what I wanted to show is what happens without SCADA, but SCADA is active. Unfortunately, that is why it's started to scale. So let me show you the scaling part here. I have the watches for the pods as well as the watch for the deployment. So in the first half of my screen, we will see all these pods which get created, because there are a number of messages to be processed, and we will see here the number of deployment has gone. We initially started with 2. I scaled it to 2 deployments, but it has gone to 30 because I have configured SCADA in such a way that it says if there are a number of messages to be processed, then scale, and it scales progressively. But because I took some time to come to the screen, it went all the way to 30. But if we look at the pods here, you can see how they have grown. So it started at 12 seconds, then 42 seconds, 27 seconds here, then 12 seconds ago. So these pods have been coming up progressively, and they are up and running now. So all the 30 pods have started to run. And what we will see in the RabbitMQ UI is now all 30 pods are acting as the consumers. And we have only 158 messages to be picked. All other messages have been picked by this consumer, and they are processing it in parallel. So what happened here was, because of my configuration of that SCADA, it realized that there is more number of messages to be processed, and it started progressively scaling my number of deployments or the replicas of my consumer deployment. And I can set this limit. So let me show you the configuration of SCADA here, or the SCADA object which I'm using, and why did it stop at 30 and why it didn't go beyond 30. So I have something called as scaled object, which is a custom resource object created when I deploy SCADA in my cluster. So SCADA stands for Kubernetes-based event-driven auto-scaling. It's a project initially started by Microsoft and Red Hat to handle the auto-scaling needs. And it gives us some of these custom resources, and scaled object is one of them. So what the scaled object does is, it looks at a particular target, and in this case, I'm targeting it for my consumer deployment. And it is polling every 60 seconds. Default is 30 seconds. I've overridden it to poll every 1 minute. So it will keep polling. And what is it polling? It is polling that RabbitMQ, and there's a queue called as hello in that RabbitMQ. As long as there are 5 messages to be processed, it is going to scale my deployment within this range. So I'm saying minimum 0. So if there are no messages to be processed, no more than 5, it will scale down everything back to 0. That is why, even though I scaled manually to 2, those number of deployments, it was getting scaled down to 0, because every minute it was checking if there is something to be processed. And the maximum replicas I'm specifying is 30. So as long as there is enough number of messages to be processed, SCADA will scale my deployment within this range. And then I also have some additional configuration here to say how it should connect to the RabbitMQ. So it is basically creating a config map with a secret which contains the connection string. It is using AMQP as the protocol to connect to RabbitMQ, and that connection string, the username password, is what is in this authentication trigger reference. So if we go back now, after some time, we should see that all these messages are processed and KEDA should start scaling down, because if there are no number of messages to be processed based on that time which I've given, now you can see all the messages have been processed by the consumers, the 30 consumers which got spun up. And we can also see the fetch size here, that every consumer was processing 75. So in our watchers, if we go back and see, in a short period of time, we should be able to see this 30 going down. It will start scaling down, and whatever number of pods are running here, they will start also to terminate. So let's wait for a few seconds for that to happen. This depends on the setting of that cooling off period. So once the KEDA has checked how much time, there is a cooling off period. I think default is 5 minutes. So after 5 minutes, it will wait for 5 minutes to see if the workload changes, and then it will start scaling back. So I will show you the scaling the watchers again here once it happens. Let me go back to the presentation while that is happening, and we can look at the other aspects of KEDA. So how did all this happen? This happened because we installed this custom project called as Kubernetes-based event-driven auto-scaling project, or it's an open source project on our Kubernetes cluster. The way this works is it has two major components. One is the horizontal pod autoscaler, and the other one is the event trigger or the source. So based on the event trigger or the source of the event, in our case, the event source was RabbitMQ here. It is going to create this horizontal pods based on the scaled object configuration. So this scaled object, it interacts with the Kubernetes API behind the scenes, and that is where it creates the horizontal pod autoscaler native object in Kubernetes, but it manages the scaling of that based on our external trigger. Kubernetes does have some internal like matrix. We have the CPU matrix, we have the RAM matrix. Based on that, we can do horizontal pod autoscaling. But in our case, since the source of our application or the messages is external, it's RabbitMQ, we don't have that fine-grained access to the RAM and the CPU core. So in our consumer, let me go back to the configuration of the consumer and show you why it might not hit in a normal scenario the horizontal pod scaling limits. I've specified resources here, and Kubernetes allows us to specify resources at individual pods. So I've set a request saying I need 1% of CPU core and initial memory of 150 MB. And the limit is 50 MB in terms 50 millicores. So 5% of the cores that a node has, and the memory is 400 MB. So within these limits, because I'm having that 75 as the fetch size, my pod might never go beyond these limits. It will always work with these amount of specified resources. So if I define a normal horizontal pod autoscaler, that will never get triggered in such scenario. And that is the reason I have to use something like KEDA, which is dependent on something outside of the normal or regular, the CPU and the RAM matrix. And in many of these scenarios, we will see that the default scaled objects or the default autoscalers which are supported by KEDA, they are more of messaging in nature. So here is how KEDA works. It has an agent which activates and deactivates the Kubernetes deployments, and it also enriches the matrix. So the horizontal pod autoscaler default matrix, they are enriched using various kinds of external scalars. And short in 1 or 2 slides, I will highlight, or I'll show you all the list of default out-of-box autoscalers which are supported by KEDA. So this acts as a glue between the native or the regular Kubernetes deployments and the external event sources. So our application can work without KEDA. So tomorrow, let's say you have a better solution to event-driven scaling, you can easily replace KEDA with something else, and your application code will not have any impact. To show this, I can delete KEDA from this cluster once it is scaled down. Yeah, so you can see here the deployment, which had 30 replicas, it has scaled down from 30 to 19, then 19 to 0, because all the messages got processed. And same thing for the pods. These pods which were running, you can see here that they are terminating. We can also go back quickly to the Octane to verify this instead of doing it on the command line. So in the Octane UI, if we go to the workloads, we should see that the number of pods running has gone down back to 0 pods for the consumer. So only 3 pods are running. One is the RabbitMQ and then the 2 producer. So as I was saying, if I don't want KEDA and if I want to use just normal resources, let me delete the autoscaler part. So I have a small script here which deletes the auto-scaling resources that I have in my cluster. Tear down. Okay. Yeah. So I'm going to delete the scaled object, which is configured, which links that deployment to the KEDA autoscaler. So now all the resources, the secret, the scaled object, and the trigger authentication for my consumer deployment has been deleted. Now let's go and regenerate the workload and see that it works fine. So instead of 3,500 messages, I'll just populate 500 messages. Okay, we have 200 as status. And if we go look in the RabbitMQ, we should see 500 messages populated here. There are no consumers right now. So let's scale back to 2 consumers and see what happens. Okay, the consumer has been scaled to 2 now, and we don't have KEDA autoscaler running now. So we should see only 2 consumers running and only 2 consumers should be consuming. So we can see only 150 messages have been picked for processing, and it will continue. We will not see the scaling happening here. So in this case, we can see that even if we delete the KEDA, the autoscaler of KEDA, the application continues to run without, as if it was without the KEDA framework. So without autoscaling, a normal application would work to continue or continue to run as is. So that is the other advantage, where it doesn't interfere with the application code as such. So we looked at this scaled object in the Visual Studio Code. So some of the key areas or key properties here is it's a custom resource, which is of a scaled object type. It looks at the scale target reference. So this has to match the deployment name. And then in terms of triggers, we are looking at a type of RabbitMQ trigger, and then the configuration for our queue length. So 5 is what I've given as the number of messages which are present in the queue for scaling to happen. We can increase this in a normal production like scenario. We won't be scaling just based on 5 messages. So For the demo purpose, I put it as just 5, but it would be usually like 1,000 or more than that. So this is what we saw in the demo. We had a RabbitMQ producer service with 2 pods, and this service was exposed as a load balancer service, which we could call from outside the cluster using Postman. Then KEDA was configured to look at RabbitMQ as the event source and the scaled target object or scaled object. And this scaled our deployment from 0 replicas all the way to 30. And then it scaled it back to 0 when there was not enough workloads to be processed. So some of the features that KEDA supports is it is event driven. We saw that when the messages were populated, it was able to quickly scale. And that is what we are seeing more and more in today's cloud native applications. We are no longer waiting for the batch kind of mode for processing to happen. I'm sure you might have seen many of these applications which give us notification nowadays. People have used, or the penetration of mobile devices has increased by many folds, and nowadays we get notified automatically via the app notifications instead of we logging into some portal and then checking the status of our request. So that is where event-driven capabilities of the applications and messaging infrastructures comes into the picture. And KEDA is very well suited for this. It makes auto-scaling very simple by providing these custom resources or custom resource definitions. It makes it very easy for us to auto-scale. It has various built-in autoscalers. So I will quickly show you the list of autoscalers in a while that it supports. These covers things like vendor resources, databases. We looked at RabbitMQ, which is a messaging system. It also has support for Kafka and others like Redis. It has support for telemetry systems and many more. And the number of autoscalers that KEDA is incorporating or onboarding is increasing day by day. When I started about 2 years back, there were hardly about 8 autoscalers. Now the number has gone to about 45. So there is a vast amount of adoption happening in terms of these built-in autoscalers. And it supports multiple types of workloads. We looked at deployment here, but it also supports things like jobs, which are other types of objects supported by Kubernetes. It's also vendor agnostic. So as long as your Kubernetes cluster is like 1.16 version or higher, you would be able to deploy KEDA on any Kubernetes installation. And from a serverless kind of infrastructure or support, it also supports Azure Functions. So let's look at some of the sources and the scalars that KEDA supports at this point in time. Since it was started by Microsoft along with Red Hat, there is a very strong support for things like Azure Blob Storage, Azure Service Bus, queues, topics, storage services, Azure Log Analytics. On the other cloud platforms, it supports AWS and GCP. GCP PubSub is supported. AWS has support for CloudWatch, Kinesis Streams, and SQS Service. When it comes to messaging, there is ActiveMQ, Kafka, Prometheus, RabbitMQ, Redis, Likless, Nets. So all kinds of commercial as well as open source messaging platforms are supported. And in terms of databases, there is support for MySQL and Postgres as well. And we can also create our own scalars if you want, which are called as external scalars. So if you want to see the complete list of autoscalars, you can go to the KEDA website and you can go to the scalar part, the scalars latest documentation. And here is the list of all supported scalars, autoscalars. So you can go into each one of this and they will give you like what are the parameters which are required for configuring this scalar, and example will also be there. So in summary, what we can say is KEDA, it's very lightweight component and it's a single purpose component. Only thing it does is, and which it does very well, is to scale the Kubernetes objects based on events. Then it is supported on any Kubernetes environment, which is 1.16 or higher version of Kubernetes. It extends the Kubernetes with event-driven capabilities. There is no duplication or overwriting of the existing functionality. And as we saw, if we don't want KEDA, even if we delete KEDA from our cluster, our regular Kubernetes objects and the application, it continues to work. It can map events from deployments, stateful sets, custom resources in jobs for scaling. And it's also flexible and safe to run alongside other Kubernetes frameworks or application. So if you have any other framework in your Kubernetes cluster, KEDA will not interfere with that. And as we looked at the number of autoscalers, there is already support for more than 45 autoscalers out of the box. So in terms of references, I would like to share some of these references for you to learn more about, let's say, Docker, Kubernetes in general. If you are new to these technologies, you can use this online resources. There is Play with Docker, Play with Kubernetes, which gives you like browser-based learning environment. There is also learning path with Linux Academy. If you have access to Linux Academy, now it's part of A Cloud Guru. So you can refer to these online courses. In terms of KEDA itself, I've given the references to the KEDA project, keda.sh, also the AKS cluster autoscaler. And one of my favorite resources, if you're learning about Kubernetes, is this 50 days from zero to hero. This is created by Microsoft with Brendan Burns, who is the co-creator of Kubernetes project. And it covers very basic as well as advanced concept. It's a combination of bite-sized YouTube videos as well as online learning resources. So I highly recommend this if you want to learn about Kubernetes. Microsoft Learn also has Azure Kubernetes Service workshop if you are specifically looking at, let's say, Azure Kubernetes Service and you want to learn more about that. My own YouTube channel has various resources. So if you want to learn more about KEDA, I created a 3-part KEDA series, which talks about how to create a cluster, how to deploy KEDA on that using Helm, and how to scale. Whatever I showed here in less than, let's say, 30 minutes is explained in much more detail in this. About Kubernetes, I also did a 6-part series for Azure Kubernetes Singapore user group. And then in general, I also do quite a lot of videos around Kubernetes. So you can find that using this bit.ly link. My name is Nilesh, and these are my social media handles. Feel free to connect. I'm happy to take any questions if you have.
Thank you, Nilesh, for such wonderful session. And I was really impressed by the demo you had there. And I'm sure with such kind of talks, people would be definitely be getting benefited more than those without demos and hands-on. I would also personally like to go and see your 1 to 50 days zero to hero stuff in Kubernetes. So definitely I'll give it a try, though I don't want to dabble at Kubernetes, but definitely learning something is not going to harm me. So as I see right now, there are basically no questions being asked by anyone. So I would request all the attendees that if you have any question, feel free to post it over here in the chat session. And we will either post it to Nilesh or we can simply unmute you so that you can have an in-detail discussion with Nilesh.
Yeah.
So Nilesh, actually, we wanted both of your sessions to be one after another so that we can have even the improving and monitoring and observability of Kubernetes with the OSS tools today. But somehow we were not able to do that due to your time crunch. So In that case, we will have to wait for another 24 hours so that we can again meet you and hear from you.
Yeah, that is even more interesting, I think.
Yeah, I think so. It would be interesting enough, because rather than scaling, people would be more required to do monitoring and observing. So,
yeah. Okay, somebody
anyway,
asking for the slide share link. Let me just post it here. Just give me a second. Back. It's basically slideshare.net, and if you search for Nilesh Gule, you will find it. Actually, my first name and last name is quite unique. So with that combination, you can almost find me everywhere. All
yeah,
my
there are other Nilesh Gule, Ghule,
yeah,
rather than Gule.
yeah. You will not find GULE anywhere else.
Okay, so definitely there are some talks about Goa and temples that I would like to take offline with you, but
Sure.
for those others who are interested on what we are going to talk, you can, such people can simply go and type Goa Inquisition and try to see where the temples of Goa has vanished.
Yes. Okay. Thank you. Thanks a lot for this opportunity. And I look forward to tomorrow's session, seeing you again. And hopefully sometime once we go back to the new normal, maybe we will meet in person and I can deliver similar talks in Surat someday in future.
Yeah, definitely. That would be our pleasure to host you over here in person at AIC Surti iLab, right? And definitely, once we meet in person, there will be more to share. But even without that, in the new norm or in the online world, we will be still sticking together and discussing about so many different issues that we can solve over here.
Yeah.
Okay, Nilesh, thanks for your time, and let us meet tomorrow again at 4 p.m. For your next talk. So thank you, and thanks all the attendees there. So we will be switching off this particular session, and we'll be continuing with the next session in the separate meeting by Yitzhak David. Okay, Nilesh, thanks and bye for now.
Thanks a
Have a
lot.
nice
My
evening.
pleasure. Have a nice evening.